Need your graphing calculator for this. Okay, so get that out. Part of what we're going to do today requires that you have a graphing calculator. Part of your homework does not require that. Being said, so if you are one of those people who is sharing a graphing calculator with someone, you realize that on the midterm, math tests are all being taken at the same time by everyone in the school. So by what is it, the 17th or 18th, whichever day, the very first day that you take tests, you need to have your own graphing calculator. So have that figured out, okay? Okay, so we're gonna combine a bunch of stuff together that we've already done in this section, okay? So in 5.6, we found other factors of polynomials, but you had been given one first. In this section, initially, you're not going to be given one first. You're just going to have to find all the roots. Okay? So, in order to find all the roots, you have to know how many roots you're looking for. And if you recall, when we did quadratics, we always ended up with 2 solutions because the degree was 2. There was one exception, and that's when we had that one double root where it just touched the x-axis, and so there was only one solution, but we thought about it happening twice, but it really only happened once. That was that x plus 1 all squared kind of thing, okay? So that can happen when we have polynomials of degree higher than 2 as well, okay? But that degree tells you how many solutions you have. If there are double roots, you just count them as twice as many as there are. And that's how you will arrive at that number. Now, like I said, yesterday, we were given a factor, which essentially was giving us a solution, and you had to find the remaining factors. Today, we're going to find all of them. So not all polynomial equations are easily factorable. Some of them are, and actually, for that matter, some of you find factoring challenging anyway, so the idea that any problem is easily factorable is probably at play here. But whenever you can factor, whether it was, all the methods we did in chapter 4, or if it was what we did in 5.5, you have those at your disposal now. And so you should always try to factor if you can, okay? But sometimes you're going to have things of degree 4, 5, 6, and you're not going to know how to factor them at all, okay? And when you run into situations like that, there are some other options. We can use the graphs to help us find some solutions. Because if we have a solution, we also have a factor. Now, anytime you have a quadratic, you can look at the graph, but you don't have to. We have methods to solve quadratics. Whether it's factoring, completing the square, quadratic formula, you don't need a graph to solve a quadratic. But when you have degrees higher than 2, you're going to have to use something else. And so when we have the graph, we use those solutions to come up with factors to find the remaining factors, like we did in 5.6. The difference is you're not going to be given a factor to begin with. You're going to have to find them right from the beginning before you can find all the remaining solutions. And then once we find all the factors, then we can find all the zeros or the solutions, because it's just a matter of setting each of those factors equal to 0 and solving. So that's what this really boils down to. When we find solutions, we have found factors. When we find factors, we can divide our polynomial by those factors to sort of reduce the polynomial and turn it into a polynomial that we know how to solve. And that might be something that's a sum or difference of cubes. We know how to solve those now. It might be a quadratic. Okay? It might be one of those equations that we factored in 5.5 that wasn't a quadratic but factors like a quadratic. Okay? And so those kinds of things are all going to be at play now. Here's an example of the type of problem that you might see. Okay, and it's going to say find all the zeros, find all the roots, find all the solutions, whatever. Those all mean the same thing. Okay. And when it's asking for the zeros, what we're thinking is that this f of x is 0. When we're looking for the graph, we're thinking of this f of x as y. We put them in the same place. Now this is degree 4, but it's not set up like a quadratic. It doesn't have, it's not a trinomial with the middle term as an x squared like what we did in 5.5. So it's not factorable right now. Okay? I mean we could look at trying to do grouping, but it's not going to work. There's 4 or more terms, so I could try to do that, but it won't work. It's not factorable. So we need to at the graph. Okay, and the graph means thinking of f of x as y. So what I want you to do right now, in your graphing calculator, I want you to enter that equation in the y equals screen, and I want you to graph it. Make the zoom window the standard 10 by 10 window. If you don't remember how to do that, hit the zoom button, go down to number 6 that says Z standard, hit enter on that, and it'll take you back to the 10 by 10 window. So go ahead and enter that, and then we'll look at that graph a little bit. Something that looks like this, okay? Now notice what I have all the way over to the right. I said we can't see enough of the graph. We can't really see, even though we can't really see enough of the graph, we can see enough. Even though we can't really see all of the graph is what that should say. Let's fix that. There, that's better. Okay, even though we can't really see all of the graph, we can see enough. Okay? Now, keep in mind, how do I find solutions when I look at a graph? Where it crosses the x-axis, right? So I'm looking for x-intercepts. And so in this case, it crosses the x-axis twice. How many solutions are there supposed to be? 4, because the degree is 4. But it only crosses twice. Now, there's one of 2 options. Either we need to zoom out to see if it crosses somewhere else, or it doesn't. And if it doesn't, what do I know about those other 2 solutions? Nope. Nope. Zach? They are imaginary. Okay, so if they do not cross the x-axis and there's still 2 more solutions, they are imaginary. So that gives us our target. One of the things your problems will ask you is to describe the type of roots that you have. And you might not be able to do that until you're done. Okay? Now, based off of this graph, what are those 2 x-intercepts? What are those values? -2 and -4. Okay, so I have zeros there. Now you have to be sure. And if you need to zoom in to make sure that they actually cross at -2 and -4, great. I know that these do. It's critical, if the polynomial is not factorable, that we find at least 1 x-intercept. Because if we can find one, then we can divide it like we did yesterday to find a new polynomial, which is probably going to be factorable, okay? In this case, I'm going to show you what we're going to do, but in most of your homework problems, the degree is going to be 3, so all you really need to do is find 1, because if you find 1, we're going to take it down to a quadratic, which you can solve. Okay, we're going to use synthetic substitution to find the remaining factors, which will allow us to find the remaining solutions. Okay? And the difference between what we did yesterday and what we did today is instead of having factors, we have found solutions. So that's why I said synthetic substitution and not synthetic division. So remember the difference, synthetic substitution, we use the same sign for that divisor. And in this case, we're going to actually do it twice. Because when I divide a 4th degree polynomial one time, it takes it to a 3rd degree polynomial. When I divide it again, I'm going to take it down to a 2nd degree polynomial, which is a quadratic, and we know how to solve quadratics. Okay? So that's what we're going to do on the next screen. So I have these zeros, -2 and -4, and the associated factors are x plus 2 and x plus 4. Okay? So that's where these solutions come from. Remember that the binomial and the solution will always have opposite signs. So the zero for this, the factor for this is x plus 2, the factor for this is x plus 4. But when I do the division, and it doesn't matter which order you do them in. So I'm going to divide this by -2, then I'm going to get a new polynomial. And then I'm going to take that new polynomial, and I'm going to divide it by -4. And I'm going to get another new polynomial. Okay? Now, it doesn't matter which way you go first. You want to divide it by -2 first? Fine. You want to divide it by -4 first? Fine. It doesn't matter. I'm going to do it by -2 first. Again, we've already talked about 2 more roots. So the first synthetic division that I'm going to do is our original polynomial. Okay, I'm missing an x to the 3rd, so that's why you see this 0 here. And I'm going to divide by, I'm going to do substitution, synthetic substitution with -2. And you're going to get a new polynomial here. So go ahead and do that. So again, it doesn't matter which one you do first. If you would have done -4 first, that's fine too. You'll end up getting a different polynomial in the middle, but the last polynomial will be the same. So, what you should have gotten. How many had that? Okay, so that just shows that -2 is actually a solution, right? Because the remainder was 0. It goes in evenly. So what I've done now is I've taken this down from a 4th degree to a 3rd degree. Because what do these numbers actually represent? Go ahead. Right. So that equals this. So I've taken it from a 4th degree to a 3rd degree. What I need to do now is, and I used -2, so now I'm going to do the same thing, except now I'm going to do it with -4 from this new polynomial, which means I'm going to take this down to a quadratic. So that looks like this. Okay, so now I divide it again. And when I divide x to the 4th by x 2 different times, it takes it down to the x squared. Okay, so go ahead and do that. Let's say that you did do -4 first. You would get a different polynomial here if you did -4 first and then did -2 down here. This answer would be the same though. Okay, regardless of the order that which you divided these by, this one would be the same. So what you should have gotten is this. Okay? What this means is that I now have a polynomial, x squared minus 6x plus 10. This is a quadratic. We don't need a special fancy way to solve a quadratic. You know how to do that. That was chapter 4. Okay, so that's what we're going to do on the next slide. What I've done is I've divided this polynomial down into something that we already know how to deal with. Okay, sometimes you're going to have an x to the 3rd, a 3rd degree. You just need one factor to get it down to a quadratic. Okay, if it was a fifth degree, you're going to need 3 factors to get it down to a quadratic. Sometimes you can get it down to a sum or difference of cubes, which we know how to factor now. We can solve those too. Okay, now here's what we're trying to do. Okay, we used the 2 solutions that we knew to turn it into a new polynomial. Once we get the solutions for this quadratic, I will have all 4 solutions, because I have -2 and -4 already. I just need to find 2 more from this. Okay? So I just have to solve this quadratic. What do you think I should try first? Factoring. We should try factoring first. Is this factorable? Factors of 10 that add up to -6. No, this is not factorable. Okay? Okay, so we have to use the quadratic formula. So do that. Remember, what are my other 2 solutions going to be? Imaginary, right? So understand that going into this problem, going into this quadratic, you should expect to get 2 imaginary solutions. So go ahead and do that. This is your setup. Okay, this is your setup. That's what it should look like. Okay, so you should have started with this. That's plugging everything in without doing any simplifying first. Just plugging it in just like that. How many had that set up correctly? Okay, good. So then, when I take this down and start simplifying it, I get 6 plus or minus the square root of -4 over 2. Okay, so it's going to happen. I'm going to get imaginaries. I can't take the square root of a negative. So this is 6 plus or minus, what is the square root of -4? 2i. All over 2. Right, so all of these can be divided by 2. So what do I get? 3 plus or minus I. Okay, so those are my 2 imaginary solutions. How many had that? Okay, good. So let's see what we actually have here. Here are my 4 roots. So now I go back and answer the question. My 4 roots. 2 of them I came up with graphically. 2 I came up with by solving quadratics. Okay? In some of your homework, you'll be able to come up with 1 graphically, and you'll have to find 2 others. Some you'll be able to find 1 graphically, and you'll have to come up with 4 others. Okay? By factoring. So when you get to your homework, all the stuff that we did in 5.5 will apply here. All the stuff that we did in chapter 4 to solve quadratics will apply here. It all builds on top of each other. So we can take all those skills that we've already learned to solve polynomial, high degree equations. 2 things. Mia's question. If you only see 1 solution on the graph, you're going to divide that polynomial by that 1 solution, synthetic substitution like we did. That new polynomial will be factorable in one form or another, and you'll be able to find the other solutions. What was your question again? Oh, we found out that the other 2 were imaginary in this problem because there has to be 4 solutions, and when we looked at the graph, it only crossed the x-axis twice. Otherwise, it should have crossed 4 times. And because it only crossed twice, there's 2 imaginaries. All right. Let's look at the last thing. So one of the problems that you're going to have is in your homework you'll have a cubic. There's 3 solutions, but you're only going to be able to tell what one of the solutions are. The other 2 are in between, and so you can't tell by looking at the graph. So you'll pull the one that you know, divide it, and then it'll take it to a quadratic that you can solve. Okay? The other thing that you're going to do is create the polynomial equation. So we can go the other way. If we're given the roots and we're told to come up with a polynomial equation, we can do that. All right. Now, the problems that you're going to be looking at are going to look something like this, and I want to explain why they're written this way, even though I didn't necessarily give you problems that are impacted by the word least degree, words least degree. Okay. In this case, if I have 3 zeros, I should have a cubic. The degree should be 3. one of the things that they like to do to you is give you so many solutions, and they give you one imaginary solution. The problem is, as we just figured out, imaginary solutions always come in pairs. They come in complex conjugates. We've talked about that before. So one of the things that they'll do is give you one of the imaginary solutions, and you'll look at it and there's like two solutions up there, and you think, oh, okay, degree 2. Well, if they only give you one imaginary solution, there has to be another one that pairs with it, so you just have to consider that. That's why they use the phrase least degree. In the problems that I've assigned, the degree will be the same as the number of roots. We could just as easily come up with a polynomial that was of degree 5 that still had those as solutions, but we're just going to minimize it as much as we can. And now this gets back to what I was talking about at the beginning, the difference between solutions, root zeros, and factors, and that whole opposite sign thing. Because, for example, if I have a root of 4, what is the factor that goes with it? It's going to be a binomial, right? Remember our binomials? So what's the binomial that goes with the solution of 4? Close. If I had an equation where the solution was 4, what was that equation probably? No. You're making it way too hard. Okay. What? X minus 4. X minus 4 gives me the solution of 4, right? So what's the factor that goes with minus 1? X plus 1. What's the factor that goes with 6? X minus 6. So if I was creating the polynomial, that's how you would do that. Okay? Now, I'm not done. Okay? What do you think I have to do now? Multiply it all. So you need to do that, please. Now, how you multiply it out is up to you. Just know you have to multiply 2 of those binomials together first and simplify, and then take that by the third polynomial. The order that you do that is up to you. I will tell you my own personal preference. I multiply the back 2 together first, because I always like to have the binomial in front. That's my personal preference. If you don't want to do it that way, I don't care. Feel free to multiply these 2 together first. It's up to you. I'm just telling you, when you see what's going to be on the screen, I multiplied the back 2 together first. Don't think yours is wrong because you didn't do it that way. When I multiplied the last together, here's what I got. I got x squared minus 5x minus 6 when I FOILed those last 2 out. Okay? Now for me, the reason I like to do it that way is because I like to have my binomial in front, so that way, I can multiply that way. Okay? But if you had a trinomial then a binomial, it would be the same thing, whatever. Okay? Multiply that out, I get this, and now I have to simplify. So what are the like terms?
X or x squared.
I got x squared. And I have x's. Is that it? Okay. So there we go. That's my polynomial that has those solutions, the least degree, and that's working the whole thing backwards. Okay? First problem that you're in the direction for your homework, the first problem, I said something about you can do quadratic formula or square root property. That means there's no x term. So that one you can do on your own. The next problem after that is a quadratic. If it's factorable, factor it. If it's not, use quadratic formula. For that matter, any quadratic you can use quadratic formula on. The rest of them, you're going to probably want to use your graphing calculator to find 1, 0, do the division, and then factor what's left. Okay? and then you'll have some problems like this.